Good morning, students. Welcome to Diamond Group of Institution online classes. Myself, Mohammad Silar, faculty in physics. In the last class, we discussed the EMF and motional EMF and energy consideration in the last class. In the today class, we are going to discuss a mutual induction, self-induction, and energy stored in an inductor. Then consider in this topic we are taking a one coil. We are taking the two coils. The first one, if this coil is connected to a battery and the coil is connected a key, we are taking the one coil and the coil is connected to a battery and tapping key K. This coil is called as primary coil. This one is primary coil. And we are taking another coil. It is placed neighbor to this coil. And this coil is connected to a galvanometer G. In the last class we discussed galvanometer is a device which measures or which shows the deflection when small current passed through it. And the coil connected to the galvanometer, this coil is called as secondary coil. Coil connected to battery and key is primary, coil connected to galvanometer is second. Now if the key is open, what is the current inside the circuit? Open circuit means current inside the circuit is 0. If current is 0, then magnetic field is also 0. We are saying magnetic field is 0. Now if the key is closed, key is closed or key is pressed. When key is pressed, it is closed. If the key is closed means current is flowing in the primary coil. Key close किए तो primary coil में current flow हो रहा है. And the current is flowing in the primary coil is in increasing order. इसका value increase हो रहा है. 0, 1, 2, 3, 4, 5 increase. In the fourth chapter, we discussed current is flowing in a conductor. Magnetic field is produced in the surrounding space. अभी current flow हो रहा. Current flow तो surrounding में क्या था? Magnetic field था. And the magnetic field lines are closed continuous loop. Then this current is flowing means magnetic field is produced. These are the magnetic field lines. Think the magnetic field lines are linked to the secondary coil. ये magnetic field lines किसको touch हो रहा है जाके? Secondary coils को जाके linked हो रहा है और touch हो रहा है. We discuss one definition. Number of magnetic field lines passing through the surface is called as magnetic flux. Number of magnetic field lines passing through the surface is called as magnetic flux. मतलब बहुत सारे लाइंस इसमें से पास हो रहे हैं. मतलब इधर क्या है हमारे पास? मैग्नेटिक फ्लक्स है phi. Then current value is increasing. Then magnetic field value is also increasing. Then magnetic flux is also increasing. Magnetic flux क्या हो रहा है इधर? Increase. Current is increasing. Magnetic flux is also increasing. This means that we are writing magnetic flux is directly proportional to current. Current value changes हो गया तो magnetic field produce हो रहा. Magnetic field produce हो गया तो वो magnetic field किसको touch हो रहा? Secondary coil को touch हो रहा. टच होने से इधर क्या हो रहा? मैग्नेटिक फ्लक्स इंक्रीज हो. They are directly proportional to each other. If in Faraday's second law, Faraday's first law, what is the statement? Whenever there is a change in magnetic flux linked with a circuit, EMF is induced. Whenever there is a magnetic flux linked with a circuit, जब भी magnetic flux change circuit में change हो रहा, and linked with a circuit, then EMF is induced. EMF is induced. मतलब इसमें क्या develop हो रहा? EMF develop. Then We are right. This is the condition. Then this phenomena is called as mutual induction. What is mutual induction? EMF induced in one coil, okay, due to change in current in the another coil. हम एक कॉइल में करंट का वैल्यू चेंज कर रहे हैं, दूसरा कॉइल में ईएमएफ डेवलप हो रहा है. दिस फेनोमेना इज कॉल्ड एज म्यूचुअल इंडक्शन. Okay, then we are writing phi is directly proportional to I. Then phi is equals to mi. What is m? M is called as constant of proportionality or mutual inductance. We are writing next one m, where m is called as mutual inductance. Mutual inductance. Okay, or also one more name is called as coefficient of mutual induction. Coefficient of mutual inductance. Okay, what is m? M is the mutual inductance, or also it is called as coefficient of mutual inductance. When current is changing in one coil, EMF is induced in the another coil. We are using the Faraday's second law. Okay, we are using according to Faraday's law. According to Faraday's law. Okay, what is the Faraday's law? Okay, in Faraday's law, we are discussing induced EMF is directly proportional to change in magnetic flux. We are writing E is equals to minus d phi by dt. d phi by dt. We are writing E means EMF, it is as it is, minus is as it is, D as it is, d by dt is as it is. Phi, what is phi? Magnetic flux. What is the value of magnetic flux? Mi. We are writing mi. The next one, E is equals to minus, take m is outside, then we are writing di by dt. Okay, E is equals to minus m. What is di? Di is the change in current. What is dt? Time. Change in current by time. If, for example, in this circuit, change in current by time is, for example, unity, its value is di by dt equals to 1. Okay, change in current in the primary coil is unity. Then we are writing E is equals to di by dt into 1, means E is equals to minus m. What is the induced EMF? What is m? Mutual inductance. Then mutual inductance of a coil is equal to induced EMF. Mutual inductance of a coil is equals to induced EMF when the rate of change of current is unity. Rate of change of current is unity. Is called as mutual inductance or coefficient of mutual inductance. Definition: induced EMF in the secondary coil, okay, when the rate of change of current in the primary is unity. Primary में rate of change of current unity हो रहा, then EMF is induced in the secondary coil. Then next one, what is the SI unit? SI unit of mutual inductance, it is SI unit of mutual inductance is Henry. It is denoted by H. Okay, dimensional formula. What is the dimensional formula of mutual inductance? Okay, the formula of mutual inductance is denoted by M. हम इधर लिख रहे हैं E is equals to M di by dt. Okay, then for example, इसको हम exchange करेंगे terms को, dimensional formula. If we exchange the terms, means we can write M equals to E dt divided by di. इसको हम exchange करें terms को, dt को हम इधर send करेंगे, di को send करेंगे, only क्या रहता है इधर M. M is mutual inductance. What is the dimensional formula of mutual inductance? What is E? E means induced EMF. EMF are also it is called as potential. EMF बोल सकते हैं हम, potential बोल सकते हैं. dt, dt means time, di means current. Then what is the dimensional formula of potential? Okay, in the second chapter, the electrostatics potential, the dimensional formula of potential is m L2 t power minus 3 a power minus 1. It is the dimensional formula of EMF or potential. dt, dimensional formula of time is denoted by t. Dimensional formula of time is t. di, di means current. Dimensional formula of current is a. Okay, dimensional formula of potential is this one. Dimensional formula of time is t. Dimensional formula of current is a. Then this t and t power minus 3 is cancelled. Means what is the value? T power minus 2. We are writing m L power 2 t power minus 2 a power minus 1 divided by a. Take this a is upward side. Power is changed. Okay. Then plus है, ऊपर आने के बाद माइनस, माइनस a power minus 1 means minus minus means we are writing m L power 2 t power minus 2 a power minus 2. This is the dimensional formula of mutual inductance or mutual induction. Self-induction. Next topic. Okay, in this case we are taking a one coil. This is a coil and a coil is connected to a battery and key. This is the battery and key. We are taking a one coil. The coil is connected to battery and key. When the key is open, current in the circuit is 0. Current is 0 means there is no magnetic field will be produced. Okay. Now when the key is pressed or closed, then current is flowing in the circuit. Current is flowing in the circuit. This is the direction of current. Think. When current is flowing in the circuit in a increasing order, current flow हो रहा circuits में कैसा flow हो रहा? In a increasing order. Current के values changes हो रहा. When current is flowing means magnetic field is produced. Magnetic field is produced in the surrounding space. Think. Magnetic field. एक round coil है, मतलब उधर से क्या होता है? Magnetic field आता. Magnetic field lines are closed continuous loop. Then magnetic field is produced. These magnetic field lines are passing through the surface means it is called as magnetic flux. Okay. Current value is changing means magnetic field is produced. That magnetic field lines are passing through the surface means it is called as magnetic flux. Okay. Current changes means magnetic flux is also changes. Think. Magnetic flux value is also changes. Okay. Magnetic flux value is also changes. 0, 1, 2, 3, 4, 5. Magnetic flux value is also changes. We are writing flux is directly proportional to I. Last topic, flux is directly proportional to I. But that one is mutual induction. This one is self-induction. Then we are writing this phi is equals to, okay, Li. What is L? L is called as self-inductance or coefficient of self-inductance. When magnetic flux value will be changed, EMF will be induced. According to Faraday's law, whenever the change in magnetic flux linked with a circuit, EMF is induced. यहाँ पर मैग्नेटिक फ्लक्स का वैल्यू क्या हो रहा? चेंज हो रहा. मतलब इसमें क्या डेवलप होता? EMF induced हो रहा. Okay, EMF is induced. This phenomena is called as self-induction. What is self-induction? EMF induced in a coil when current is changing in the same coil. सेम कॉइल में करंट का वैल्यू चेंज हो गया तो ईएमएफ क्या हो रहा? डेवलप हो रहा. ओके, दैट इज कॉल्ड एज सेल्फ इंडक्शन. ओके, फॉर एग्जांपल एक पर्सन है बोल के हम थिंक करेंगे. ओके, एक पर्सन है और वो क्या कर रहा? खुद से पैसा कमा रहा. ओके, देन खुद से पैसा कमा रहा है तो खुद से पैसा क्या कर सकता है? खर्च कर सकता है. मतलब वो उसको क्या कर रहा, खुद से पैसा कमा के खुद खर्च कर रहा, मतलब एक कंडीशन हो गया। दूसरा कंडीशन, एक पेरेंट्स है और एक चाइल्ड है बोल के हम थिंक करेंगे। अभी चाइल्ड के पास पैसा आना बोलते, एक बच्चे के पास पैसा आना बोलते किधर से आता है, पेरेंट्स के पास से आता है। मतलब वो क्या हो गया, म्यूचुअल इंडक्शन। पेरेंट के पास से पैसा किसके पास आ रहा, बच्चे के पास आ रहा, म्यूचुअल। सेल्फ इंडक्शन मतलब खुद से कमा रहा। ऐसा ही वर्ड्स है, ईएमएफ इज इंड्यूस्ड इन ए कॉइल ड्यू टू चेंज इन करंट इन द सेम कॉइल। Okay, that is the definition. Okay, we are ready. Phi is directly proportional to I. Phi is equals to Li. Then what is L? Where L is called as self-inductance. Where L is called as self-inductance, or also it is called as coefficient of self inductance. Coefficient of self inductance. Okay, SI unit. What is the SI unit of self inductance or mutual inductance? SI unit is same and the SI unit is Henry. It is denoted by H. It is denoted by H. Dimensional formula of self inductance or mutual inductance, both are same. We are writing, okay, m L power 2 t power minus 2 a power minus 2. This is the dimensional formula of mutual inductance. Then next we are writing, when current is changing in the coil, EMF will be induced. Then according to Faraday's law, we are writing, according to Faraday's law, then E is equals to minus d phi by dt. Then E is equals to minus d by dt. Phi means magnetic flux. Magnetic flux equals to, what is the value, Li. Substitute this value here, Li. Then take the L value is outside, then we are adding di by dt. What is L? Self-inductance. What is di? Change in current. What is dt? Time. Then change in current in the coil is unity. Okay, time and current का value क्या हो रहा, change हो रहा. Then its value is, think, change in current in the circuit is di by dt equals to 1 ampere. Okay, then change in current is unity, then 1, then we are writing into 1, then E is equals to minus L. Okay, self inductance of a coil is equals to induced EMF in the coil when the rate of change of current is unity. This is the definition. Okay, self inductance or coefficient of self inductance. Okay, self inductance of a coil is equal to the EMF induced in it. Okay, self inductance of a coil is equal to the EMF induced in it when the rate of change of current is unity. Rate of change of current is unity. ये दोनों equals कब रहते हैं, when the rate of change of current is unity. Okay, this is the concept for 2 marks or 1 mark or 3 mark questions. Define questions are, define self induction or self inductance or mutual induction or mutual inductance. Definition: write the SI unit of self induction is Henry. Write the SI unit of mutual inductance is Henry. Both are same. Dimensional formula of self inductance and mutual inductance is also same. What is the dimensional formula? M L power 2 t power minus 2 a power minus 2. Next topic, most important for 5 mark questions. Very important. Okay, very important for 5 marks. Energy stored in an inductor. Okay, energy stored in an inductor. Okay, energy, as you know already in PUC first year we discussed what is energy. Okay, capacity to do the work is called as energy. Capacity to do the work is called as energy. एनर्जी स्टोर्ड इन एन इंडक्टर, हम एनर्जी को स्टोर कर रहे हैं, किसमें स्टोर कर रहे हैं? इंडक्टर. Okay, what is inductor? It is an element in an electric circuit, okay, which is tightly wound by insulated wire. Okay, insulated wire. For example, we are taking one insulated wire which is tightly wound. Okay, and this wire is opposes the change in current in the circuit. And the symbol of inductor is, this is the symbol of inductor, as you know already. In third chapter we discussed the symbol of resistor is this one, symbol of capacitor is this one, okay, symbol of cell is this one, okay, this is the symbol of resistor, this is the symbol of capacitor, this is the symbol of battery, okay, this is the symbol of inductor, and which is opposes the change in current in the circuit. Consider a inductor. It is denoted by L. This inductor is connected to a battery and key. An inductor is connected to a battery and key. Just we discussed here. Okay. Connected to a battery and key. Now, key is open, current is not flowing. Okay, then current in the circuit is 0 when key is open. Now when the key is pressed, the key will be closed. When key is closed, current is flowing in the circuit will be increases. Same self-induction type. Okay, when key is closed, current is flowing in the circuit. When current is flowing in the circuit, this current will be produce a magnetic field. Okay, when magnetic field is produced, that magnetic field lines are passing through the surface, means it is called as magnetic flux. Then magnetic flux is also increases, current value is increases, means magnetic flux is also increases. They are directly proportional to each other. Just we discussed that. When the magnetic flux linked with the circuit is changes, then EMF is induced in the circuit. हम वही पॉइंट्स को रिपीट कर रहे हैं. करंट का वैल्यूज चेंज हो रहा, मैग्नेटिक फील्ड प्रोड्यूस हो रहा, वो मैग्नेटिक फील्ड का वजह से क्या आ रहा? मैग्नेटिक फ्लक्स आ रहा. करंट का वैल्यू चेंज हो गया तो मैग्नेटिक फ्लक्स का वैल्यू भी क्या हो रहा? चेंज हो रहा. अकॉर्डिंग टू फैराडेज फर्स्ट लॉ, whenever there is a change in magnetic flux linked with a circuit, EMF is induced. क्या डेवलप हो रहा? EMF डेवलप हो रहा. We are writing EMF is induced. EMF is induced. And the induced EMF, what is the formula? E equals to minus L di by dt. E equals to minus L di by dt. What is L? L means inductor. ये EMF डेवलप हो रहा, किधर डेवलप हो रहा? इंडक्टर में डेवलप हो रहा. That symbol is L. di by dt. di by dt means change in current by time. This induced EMF is always opposes the negative sign, shows that opposition. ये EMF क्या कर रहा? अपोज कर रहा. किसको अपोज कर रहा? द रेट ऑफ चेंज ऑफ करंट. करंट का वैल्यूज को क्या कर रहा है? नो अपोज कर रहा. ओके, EMF डेवलप होने से वो क्या कर रहा? करंट का वैल्यूज को क्या कर रहा? अपोज कर रहा. Then it is opposing to the current. If it is opposing to the current, means current value will be decreases and becomes 0. अगर ये अपोजिशन कंटिन्यूअसली चला तो ये वैल्यूज क्या होता है? डिक्रीज होके क्या होता है? 0 होता है. बट टू स्टैब्लिश द करंट इन द सर्किट, हम करंट को सर्किट में स्टैब्लिश कर रहे हैं. ओके, टू स्टैब्लिश द करंट इन द सर्किट वी हैव टू अप्लाई द एक्सटर्नल वोल्टेज. ये सर्किट्स में अपोजिशन होने के वजह से करंट का वैल्यू क्या होता है? डिक्रीज होता. ये करंट का वैल्यू डिक्रीज नहीं होना, करंट ये सर्किट्स में ऐसा ही कम फ्लो होना बोलते हम क्या करना पड़ता है? एक्सटर्नल वोल्टेज क्या कर रहे हैं? हम अप्लाई कर. व्हेन एक्सटर्नल वोल्टेज इज अप्लाइड मींस थिंक some charges are transferred, that charge is called as dq. Then we are writing work done or small work done. Small work done. Some charges are transferring. Okay, work done formula in PUC first year we discussed. Work done means force into displacement. Okay, in electrostatics potential we discussed the formula is okay W equals to V into Q. We are writing small work done dW equals to minus E into dQ. What is E? E means induced EMF. What is dQ? dQ is the charge which is transferring. Okay, then we are writing
equals to minus E value minus L di by dt into dq. Then dw equals to minus minus plus, minus into minus means plus, then leave it L di by dt into dq. The next dw equals to minus, हमें टर्म्स को एक्सचेंज करेंगे, dq को इधर लिखेंगे, di को इधर लिखेंगे, then we are writing dq by dt into di. हम कुछ नहीं किए, ये dq को इधर लिख रहे हैं, di को इधर लिखे, जस्ट चेंज किया टर्म्स. dw equals to L dq by dt. What is dq? Charge. What is dt? Time. Then as you already, the rate of flow of charge is called as current. dq by dt means I. We are writing in place of dq by dt is I di. It is our equation number 1. This is for small work done when some charges are transferring to establish the current. Next one, total work done. Total work done. Okay, establish the current from 0 to I. Total work done. Establish the current from 0 to I. Then total work done. To calculate the total work done, we are integrating this equation. Okay, we are writing integration of dw equals to integration of Li into di. What is the limit here? 0 to I. Because initially current कितना था सर्किट में 0, बाद में कितना सर्किट एस्टैब्लिश हो रहा I. We are writing 0 to I. Integration of dw. What is the value of integration of dw? W. We are writing integration of dw value is w. Take L is outside. Okay. Then inside the integration I into di. The limit is 0 to I. Integration of I. What is the formula of integration of I? Integration of I. Integration formula. Okay, x. For example, x we can think of x n plus 1 by n plus 1. Then what is the value I? Which will means integration formula. X equals to x n plus 1 by n plus 1. This is the formula of integration. But हम इंटीग्रेशन किसको कर रहे हैं? I को कर रहे हैं. I को कर रहे हैं. Then we are writing what is the value? Nothing. Which we power means 1 plus 1 divided by 1 plus 1. Then we are writing I square by 2. It is the integration I. Then W equals to L. Integration of I means we are writing I square by 2. Okay. Then what is our limit? 0 to I. This is the limit. Next, multiply this value to this limit. हम वो values को limit से multiply कर रहे हैं. Then W equals to L. Okay. I square by 2 minus of 0. I square by 2. I square by 2 minus of 0. Then next, W equals to I L square by 2. Or also we can write I L square by 2. This work done in establishing the current in the inductor is, this work done is stored in the form of potential energy. Okay, the work done is stored in the form of potential energy. Potential energy is denoted by U. Then in place of W we are getting W equals to U equals to half L I square. This is the energy stored in N inductor. This is the most important topic for 5-mark question. Okay, energy stored in an inductor. The equation is half L I square. और एक 1 mark में question आता which type of energy stored in an inductor. Which type of energy stored in an inductor means the types of energy stored in an inductor means that energy is potential energy. Which type of energy? Potential energy.
The next topic is eddy current. Most important for 3-mark question. Okay, for 3 marks, most important are very important. Question: define eddy current, okay, and write their applications. Okay, then look this side. We are taking a one conductor. The definition is given. The eddy currents are induced current, okay, in bulk piece of a conductor. Eddy currents are induced current in bulk piece of a conductor. ये current generate हो रहा, किसमें generate हो रहा? Bulk piece of a conductor. When they are subjected to change in magnetic flux. वो कंडक्टर को हम किधर रख रहे हैं? मैग्नेटिक फ्लक्स में रख रहे हैं. When subjected to magnetic flux means the current will be induced. That current is called as eddy current. Look this side. We are taking a one piece of a conductor. This one is called as thing. This one is conductor. Okay. This conductor thing surrounding by the magnetic field. Okay. And these cross lines are indicated by the magnetic field. If the magnetic field value will be changes, ये magnetic field का values क्या हो रहा? Change हो रहा. And these magnetic field lines are passing through the conductors thing. ये magnetic field का value क्या हो रहा? Change हो रहा. और किस में से pass हो रहा? Conductors में से pass हो रहा. Number of magnetic field lines passing through the surface or conductor, okay, is called as magnetic flux. Then magnetic flux value is also changes. Whenever the change in magnetic flux linked with the circuit, then current is generated or EMF is induced. Then ये circuits में क्या होता है? Current क्या हो रहा है? Generated. Okay, these current are called as induced current. Okay, this current is called as induced current, is also called as eddy current. Eddy current. What are the applications of eddy current? Okay, the electromagnetic damping. हम किधर यूज कर रहे हैं? इलेक्ट्रोमैग्नेटिक डैम्पिंग में यूज कर रहे हैं. एंड नेक्स्ट वन इंडक्शन फर्नेस. ओके, इंडक्शन फर्नेस में यूज कर रहे हैं. एंड नेक्स्ट वन मैग्नेटिक ब्रेक्स. किधर यूज कर रहे हैं? मैग्नेटिक ब्रेक्स में यूज कर रहे हैं. एंड नेक्स्ट वन एनर्जी मीटर. ओके, these are the important topics only for 3 marks. What are eddy current and define and write the applications of eddy current. In the today class we discuss the eddy current, energy stored in inductor, most important for 5 marks. Next we discuss the self induction, mutual induction, definition, SI unit and dimensional formula. Okay, up to in this class. Okay, this class is very important. Next class also most important, we will discuss. Okay, thank you.